that, we have to know what an alternating series is. Okay? So here's what an alternating series really is. It's a series whose terms alternate between plus or minus, minus or plus. Okay, so you say, really? Do I have terms that alternate between plus or minus, minus or plus? Yes, we do. So like, for example, you have series that look like this. Okay. So when I plug in n is 1, say, is that, what are the terms here, right? This is going to be what? Right? You're going to get this, really it's going to be 1. Yeah. 1 minus 1/2 plus 1/3 minus 1/4 plus. So those are the alternating terms there. They alternate between plus or minus or plus. What I call this portion here, that's like the alternating mechanism. Okay? So you're going to have an alternating mechanism. Okay, so if you start to look at these terms, you can say, oh, that starts at negative 1/3, and then it got negative 1/3 to the second power, and then it goes back to a negative sign. 3 cubed, and then it goes on forever. So this is alternating between minus and plus. And again, this here is the alternating mechanism. So I want to point out to you that you have these alternating series with an alternating mechanism built in, right? Okay, and so here's what they want you to consider, right? They're going to say something like this. You're going to let a series that looks like this, negative 1 to the n, bn, or negative 1 to the n minus 1, bn, n is 1 to infinity. So you're going to have series that have an alternating mechanism there. And then you have these terms, bn. These are all like positive terms, by the way. And then they'll say, okay, and bn are positive terms for all n. Okay, so we're going to consider these alternating mechanisms with a series. All right, and so now you say, okay, well, what is this? Well, you have what's called the alternating series test. So here's the thing. Okay, so if this series, they're going to say this, looks like this. Let's erase this. If this series, again, by definition, you're going to say has B1 minus B2 plus B3 minus B4 and so on. This is your series. If this series satisfies the following. You say Bn is less than or equal to Bn for all n. You say, what does that mean? It means this Bn portion is decreasing. Decreasing. Okay. And not only is decreasing, the limit of Bn as n goes to infinity has to equal 0. Okay, so here's what you want. You want that these Bn terms right in here to be decreasing. Those terms are decreasing. And the limit is what? 0. This is your alternating mechanism. Then you have the following. Then the series converges, right? So you have that n minus 1 Rn, then the series converges. There it is. Okay, so here's an example here. Okay, so you might say, okay, well, what's an example of this? Here it is. That's the alternating mechanism. Your Bn is 1 over n. Now, what do you guys know about this particular series, right? Is this Bn series, right? Isn't this, by the way, a decrease? Isn't this Bn decreasing? Isn't that a decreasing terms? How do you know that's decreasing, right? So you might say, well, is f of x 1 over x, isn't that decreasing over that interval? Right? So sometimes people say, oh, that derivative is negative for x greater than 0. So it's so Bn is decreasing. And you have an alternating mechanism. What else do you know about the limit? What's that limit? That limit equals what? 0. So what could we say? What do we say here? This series, what? Converges by the alternating series test. There it is. Okay, so there's a very, very simple example. What do you guys think? Is that okay? All right. So let's give you guys another example. Let's go over some examples of this test. So I have a series here now that looks like this. So what you do is you say, okay, here's my alternating mechanism, but this portion is defined to be what? Bn. So I want to remark again to you guys that Bn is what? Well, this sequence is decreasing. That's decreasing. Right? You say, how do I know? Because that derivative will be negative over that interval, for these particular terms. So you can kind of look at that and you go, oh yeah, that derivative's negative for x greater than, 0. Okay, so then we have to check what's the limit now here, right? So how do you do this? Right? How do we show that limit here? Now, well, you know what? You can kind of, you can do L'Hopital's rule, or you can kind of do this. Let's see if this works out, right? 2 plus 3 over n. Yeah, the square root of n over n. If I divide every term by that n, right? Let's see if this helps me. What is that numerator? Isn't that numerator going to be 1 over the square root of n? 2 plus 3 over n? Double check. This is going to be what? Isn't that 0 over 2 plus 0, which will be 0 over 2, which equals 0. So what does that mean if that limit equals 0? This means it what? You got convergence by the what? Alternating series test. Okay, what do you guys think? Is that okay? And you could use L'Hopital's rule as well. You can do that. Okay, so Bn is n e to the minus n. Bn is n over e to the n. Okay, and again, this is also going to be a decreasing situation. Okay, so you might say, well, okay, here's a decreasing. You go, what if I look at this function x over what e to the x? The limit of Bn is the limit of n over e to the n, right? So what does that mean? So what do you get here? What's this limit? Do you guys know what that limit is? That limit is also 0. How do you guys know that limit is 0? Huh? Yeah, you can actually say by L'Hopital's rule, right, you're going to have x over e to the x. That's infinity over infinity. So by L'Hopital's rule now, we take the derivative of the numerator, which is 1 over the denominator, and that limit is 0. So, yeah, you could do that. Okay. And I want you guys to take a look at this example. It kind of seems like a silly example, right? What if I give you something like this? Just kind of to throw that out there. Well, first of all, I'm going to say this, you guys, because this is kind of an important thing. You might say, is this an alternating series? Say yes. Isn't that alternating? But what's the problem here? If you look at the first term, that's 1 minus 2 plus 3 minus 4. That goes on forever. So if you said, you know what, I'm going to try this Bn here, why can't you use, I'm going to give you guys this fact. You cannot apply the alternating series test, right? You can't apply this test. Yeah, because Bn is what? Bn is increasing. So the alternating series test does not apply. Is that, you guys okay with that? Because remember, this is an if-then statement. If you have this situation here, if you have all of this, then you must be decreasing though, right? You have to have a decreasing series. This means Bn is decreasing, by the way. Let's write it down that way. Okay? Another way to say Bn is decreasing. So you're violating the assumptions. You're violating the assumptions. You okay with that? You cannot apply. Okay. But I want you guys to note something here. Does the series converge or diverge? And if so, we have to know why. Okay, you guys okay with that? So I know it seems like a very simple or a silly example, but it isn't. Okay, I'm going to go over here. You guys with me on that? I'm going to call that AN. AN is -1 to the n minus power times n. What do you guys know about that limit? Do you guys know what that limit is? What is this limit equal to? Well, this is a does not exist. Why? Because where this limit goes here is to plus or minus infinity as what? As n gets big. Is that right? Isn't it going to two places, plus or minus infinity? Well, what does that mean? Because that's an important detail. What do you think that means? That means the series what? Diverges. But don't just guess, because at this point, what students do is they guess. They go, okay, converge, diverge. They just guess without justification. And you can't give them points because they go, I got a 50-50 chance. You'll get a 0 if you just say diverge. You won't get credit. You go, what? Yeah. What do you guys notice that I say here for every one of these? We justify it by the alternating series test. It's justified. It's not guess. Converge, diverge, 50-50 chance. I got them all right by guessing, type of thing. Can't do that, right? So why am I saying that this thing diverges? There's a very good reason. What do you say? Yes, by the divergence test. Absolutely. Or say test for divergence. Doesn't matter. Divergence test or test for divergence. You want to let people know that, because what happens, if you guys remember, if the limit, what was that test, by the way, right? If the limit of an is not 0 or does not exist, then we can say the series what? Diverges. This is the test for divergence. So I want to bring that up because it shows up. Anyway, just want to throw that out there. And then you got this kind of interesting situation here. This is an alternating mechanism. So sometimes they sneak it in. This is like saying you have -1 to the nth power. That's the same kind of thing. That's an alternating mechanism. So sometimes they'll sneak in that cosine n pi. And it's like the same as -1 to the n. And so now here again, you might say, okay, here's my Bn. We'll say Bn is n over that 2 to the n. And of course, this is also what? Decreasing. Okay, how do you guys know that this thing is decreasing? Again, you could look at the function, fx. Notice again, the denominator is increasing much faster than your numerator. That's going to be a decreasing function. Okay, so if that's my function, so you guys know, what can happen is that derivative is going to be negative for those positive values of x. And then also similarly, you say, okay, I know it's decreasing. What is the limit? What is this? Anybody know? What happens here? What's going on here? The limit, x goes infinity of x over 2 to the x. You guys remember that? That's going to be what? You say infinity over infinity. But by L'Hopital's rule, isn't that going to be 1 over natural log of 2 to the x? Isn't that the derivative of 2 to the x? And then this thing equals what? 0. So that means this limit is also what? 0. So what do we know about convergence? We can say this thing converges, right? It's finite, converges. By the alternating series test. So it's not just you're showing this stuff. It's gonna anyway. Okay, so here's another alternating mechanism. So you're going to say, well, what's going on with this particular difference, right? So just to kind of remind you guys, if I look at this function here, so even if I went to Desmos, you go, okay. Just to kind of let you know, y equals the square root of x plus 1 minus square root of x. Okay, you guys see how that's a decreasing function, by the way? Right? You guys know what I'm saying? Maybe you can't see it, but isn't that decreasing function? So you guys know that, right? So it's a decreasing function. So I want you guys to know that this is decreasing, right? But now that you know it's decreasing, we need to take the limit of this. Okay? And notice what happens when you take this limit. You're going to get now what? Infinity minus infinity. What's that? Well, you've seen this. There's a couple of things. Yes. Like in Calculus 1, you guys remember Calculus 1? Calculus 1, you had the same situation. That they had you take that limit in Calculus 1 well, this is going to be an indeterminate difference, right? So how did you handle this, if you guys remember? Whenever you have this difference with radicals, there's a way to do it. Is that right? What's it going to be? You multiply the top and the bottom by the conjugate. You guys remember that? That's the algebra. So the numerator this is by FOIL, you end up with 1 over what? The square root of x plus 1 plus the square root of x. So that the limit now, as x goes to infinity, 1 over the square root of x plus 1 plus the square root of x equals what? 0. Okay, now that should make some sense because this isn't this, if you guys remember, y equals 0. See that limit? Isn't there a horizontal asymptote at 0? Right? You guys see what I'm saying? You got a horizontal asymptote at 0. So this is kind of the calculus 1 if you wanted to say, oh my God, this is calculus 1. Yeah, that's under the hood. This is calculus 2, though. And so anyway, what do we know about this particular limit? This equals what? This equals 0. So if that equals 0, we have what? Convergence by our alternating series test. So this is why calculus 1 is kind of, you know, it's under the hood, I guess. And notice something about this here, right? This is also a very good example here, right? So this is my Bn. Bn is going to be what? 3n over what? 4n minus 1. Okay, so, oops, sorry about that. Okay, let's take a look here. What do you guys know about this situation, though? Is this a decreasing function, right? If I said, okay, what does Desmos say about this curve? Y equals what? 3x divided by what? 4x minus 1. So you know that this thing is decreasing. Is that right? Isn't that function decreasing? Okay. Sorry, just multitasking. Okay, so what's left for you guys to do then? You got to now take the limit n goes to infinity of bn is now the limit of what? 3n over 4n minus 1. Okay? What does that give you? Huh? Yeah, you can use calculus 1 or you can use calculus 2, right? You can divide every term by n, is that right? So I can even go back to calculus 1 for this. Here's the limit 3 over 4 minus 1 over n. And what do you end up with? This is what? 3/4. No. What does the alternating series test say? Let me go back. Okay. So let's go through, we got to do the logic here, right? Logically speaking, it's decreasing. However, the limit is not 0. So here's the point. I cannot use the alternating series test. That's the point, logically speaking. So if I go all the way back down here, here's what we can say, okay? We cannot apply the alternating series test. No. So what do you think we should do? Let me give you guys a hint. Okay. Tell me what you guys think about this here. Isn't this an? What's the limit of an? You say, oh, I can take the limit of, what is the an? -1 to the n, 3n over what? 4n minus 1? What's this limit going to be as n goes to infinity? That's plus or minus what? 3/4. What does that mean? Yep. This limit, what? Does not exist. You can't go to two places. That does not exist. Now what can we say? Then that means our series, what's the story? Diverges. Yes. This diverges why? By the divergence test. And that's what you're here to learn. Okay, you guys okay with that? So it's an interesting phenomena. So here's what I would say to you. If you notice the convergence here is not 0. Like if you try to apply the alternating series test and that value goes to a constant, I would say get happy. You say, why? Because if you apply the divergence test to it, it's going to go to plus or minus that finite value. and then it diverges by test for divergence. So even though it's failing, you fail to apply the test because it doesn't satisfy the assumptions. The fact that you had decreasing and it was constant, like this, you go, oh, that's 3/4. That's not 0. If it was 2 or if it was 5, when you apply, or 1/2, doesn't even matter. When you apply then this divergence test, it'll be a does not exist because it's going to 2 values. It's alternating between 2 numbers. So that's kind of that's the divergent situation there. Anyway, so that's what I have to say about that. That's kind of a remark that's interesting. And then we'll follow up with this kind of thing. To say if you had -1 to the n plus 1 n squared over, n cubed plus 1. Okay. Here's your alternating mechanism. Okay, now this is going to be a decreasing situation as well, right? So we know this is decreasing. And sometimes people aren't sure, so you say, well, how do we know? Well, do you guys know if the denominator power is higher than the numerator? Like in this case, if you said, okay, I have x to the what? Second power divided by what? X raised to the third power. Okay, so here's your curve now. So that's decreasing. The limit's going to be 0, by the way. You can even tell by this curve here, right? You guys see my point? Anyway, so even going back to calculus 1, if we said, oh, we want to look at the function. Yeah, that function is decreasing. You could do calculus 1, but whatever. Even looking at the graph, it's a decreasing function. Okay, now we have to do the limit now. Okay, so you can actually do calculus 1 here by dividing every term by that n cubed. Right? So now you get the limit of, you say, is that n squared over the n cubed over n cubed over n cubed 1 over n cubed. Zero over 1 plus 0, which is 0 over 1, which is now 0. So we say this thing what again? Converges by your alternating series test. So this is kind of, like I said, this is a very, very special class of, I should say, what? It's a very special class of limits. Yeah, anyway. Let's try this one here. Okay, so you see something like this, and you say, well, what do I do with that little power here, right? Well, by properties of algebra, isn't that -1 to the n? And then I have what? N over 3 to the n. Right, just by a little bit of that algebra. Then you have this alternating mechanism. So here's my Bn. So now we say, okay, here's our Bn. So, okay, now we might say, well, what kind of function am I looking at here? Isn't that increasing? I don't know. Let's see. That might be an increasing situation. So, what do you guys see going on with this function there, right? This thing is what? This isn't even decreasing. This is increasing. So, I'm going to say to you guys, you can't apply the alternating series test. Is that right? That's an important detail. But I'm going to recommend you look at this question this way. Okay, so get rid of the alternating portion. This isn't even, this is completely increasing. So call this now, don't call it Bn anymore, call it what? An. So since An is -1 to the n over 3 to the n, you have that limit of An becomes a limit of what? Okay, where does that go? Let me give you guys a hint though. Because there's an alternating mechanism here. You see this here? That's going to go to plus or minus. Is that true? But then you might say, but what is the limit here? I need to find the limit now as x goes to infinity, x over 3 to the x power. Does anybody know where that goes to? Well, this thing goes to infinity, but the question is why? Let's see, what time do we get out of here? Is it 11:35? Okay. You say, why am I asking for this? Does this look familiar to anybody? You guys remember L'Hopital's rule? Okay, so if I said to you guys this, as x gets big, x, natural log x over 3 gets what? Big. Is that true? In other words, natural log y goes to infinity as x gets big. So so natural log y, in other words, this goes to infinity. Is that right? Anyway, so I'm going to say this to you guys. Y goes to infinity, and even in Desmos, if you look at that curve, isn't that curve going to infinity? Anyway, so moral of the story is this limit is what? Plus or minus infinity, which is another way of saying what? Does not exist. So that means this what? Diverges by the divergence test. So I wanted to give you guys another example of this where you've seen the limit goes to plus or minus finite value. That does not exist. Plus or minus infinity. That does not exist. There you go. Anyway. So, ladies and gentlemen, this is the what? Alternating series test. Let's go to the